Hello, space enthusiasts. Have you ever wondered how Mars transformed from a potentially habitable world into the barren wasteland we see today? Well, NASA's Curiosity rover has been hard at work in 𝙤𝙃 crater, uncovering some fascinating new clues about Mars' ancient climate. Curiosity's recent findings are giving us a clearer picture of how the red planet's climate shifted dramatically. Researchers have been analysing carbon-rich minerals called carbonates, which are crucial for understanding past environments. These carbonates, found in 𝙤𝙃 crater, suggest that Mars experienced extreme evaporation. This points to a climate that could only support transient liquid water, fleeting, short-lived moments of wetness. David Burt from NASA's Goddard Space Flight Center explains that the isotope values of these carbonates don't match an ancient environment capable of supporting surface life. However, this doesn't entirely rule out the possibility of life existing underground or in earlier periods before these carbonates formed. Isotopes, different versions of elements with varying masses, play a key role here. When water evaporates, lighter isotopes of carbon and oxygen escape into the atmosphere, while heavier ones accumulate and get incorporated into carbonate rocks. These carbonates serve as climate records, holding details about the ancient Martian environment, such as temperature and water composition. The study proposes two potential scenarios for how these carbonates formed in 𝙤𝙃 crater. In one scenario, they formed through a series of wet-dry cycles, indicating fluctuating conditions that alternated between more habitable and less habitable environments. The other scenario involves formation in extremely salty water under cold, ice-forming conditions, suggesting a less hospitable climate where most water was locked up in ice. Jennifer Stern, also from NASA Goddard, notes that these scenarios represent different climate regimes with varied implications for habitability. Wet-dry cycles could have created temporary, more favorable conditions for life, while cryogenic temperatures would have made the environment much harsher and less supportive of life. The heavy isotope values found in Martian carbonates are notably higher than those on Earth, indicating extreme processes at play. This suggests significant evaporation and the preservation of these isotope values against processes that might lighten them. Curiosity's sample analysis at Mars, SAM, and tunable laser spectrometer (TLS) instruments were key to these discoveries. SAM heats samples to nearly 1,652 degrees Fahrenheit, releasing gases that TLS then analyzes. This groundbreaking work, funded by NASA's Mars Exploration Program, was made possible by the collaborative efforts of NASA's Jet Propulsion Laboratory and Goddard Space Flight Center. So, there you have it. Mars' journey from a potentially habitable world to its current inhospitable state is becoming clearer, thanks to Curiosity's relentless exploration. Stay tuned for more exciting discoveries from the Red Planet. Thanks for watching, stay tuned to Science Rise On, and remember, keep looking up.